Subscribe to the channel and press the bell icon for more educational videos.
Hi everyone. Now we will discuss about what is beam, shear force, bending moment, sign convention, a variation of shear force and bending moment in the beams. Okay, let us go with a beam. Now what is beam? A beam is a horizontal member. For an example, if you take a frame structure, this is a frame structure. It contains column, a beam, okay, and a footing, right? So column is a vertical member, beam is a horizontal member. The function of a beam is it will carry a load from a slab and it will transfer a load to the columns, and column will transfer to the footing, and through it will transfer to the ground. Okay, this is the concept. A beam is a horizontal member. Beam is a horizontal member. Okay, now, so when we are analyzing the beams, we will calculate a shear force and bending moment, and we will draw shear force diagram and bending moment diagram. So fine, let us discuss what is shear force. What is shear force means? A shear force means a two equal and opposite forces acting at the same point, which will try to break the section or try to shear the section. For an example, take a simply supported beam subjected to point load at the center. Okay, since it is a simply supported beam, the load is concentrated at the center. This load will be distributed equally on both the supports. That means total load is 10 kilonewton. It will be distributed on both the supports. That is 5 kilonewton, 5 kilonewton. Okay, now let us consider a section XX at a distance of x from left support. Now I will calculate a shear force at this section. Okay, I can calculate shear force from left side or right side. Okay, now you will understand whether you calculate from left side or right side, it will remain same. Okay, now for an example, here I have drawn a section. Okay, for up to here, only left of the section, only this 5 kilonewton is acting, which is trying to push upward. Correct or not? This load is trying to push upward. By how much? 5 kilonewton. Similarly, you just calculate from right side of the section. Right side of section XX. Here, right side of the section XX means now minus 10 kilonewton because it is acting downward. Another force is there, 5 kilonewton, which is acting upward. So I will take what? Positive 5. So it will become how much? Minus 5 kilonewton. So minus 5 kilonewton means it is acting downward. That means right of the section is how much? 5 kilonewton is acting downward. Similarly, left of the section 5 kilonewton is acting upward. This is called as shear force. Okay, so that means at the same point, two equal forces acting in opposite direction that will try to break the section, which is called as what? A shear force. Right? Hope you understood. Now, from this concept you would have understood a shear force can be calculated either from left side or right side. Okay? Now, so what is the use of a shear force? Why we will calculate a shear force? By using the shear force value, you will calculate a shear stress. What is shear stress? Shear stress means shear force by area. Right? This you would have studied in first module itself. Right? Now this indicates as the shear force increases, shear stress will increase. Now, so based on the shear force value, okay, we will calculate shear stress. Based on the shear stress, to resist the shear stress acting on the beam, this shear stress again depends upon what? Loads. Okay, based on the shear stress value, we will design what? As stirrups. Stirrups is to resist what? A shear stress. Okay, hope you have seen in the beams in the reinforcement section, they will give a rectangular stirrups. So this is purely to restrict or resist what? A shear stress. So hope you understood why we have to calculate what? Shear force. So based on the shear stress, they will calculate what? They design the stirrups and also a spacing of the stirrup. That's why we need to calculate what? A shear force. Okay. So now we will go with what is bending moment. What do you mean by bending moment? Bending moment is, we can say it is a rotational effect caused by a force. It is a rotational effect caused by what? A force. How to calculate rotational effect means the bending moment is defined as mathematically it is a force into perpendicular distance. Force into perpendicular distance. Right? Force into perpendicular distance. Correct. So force into perpendicular distance wherever you are measuring the moment. Okay, now I will take the same example which I have taken previously, a simply supported beam subjected to point load of 10 kilonewton at the center. So since it is acting at the center, this load will be distributed equally on both the supports. That is, let's reaction is 5 kilonewton, 5 kilonewton. Right. Now let us take a section XX at a distance of 1 meter from left support. Right. So now I will calculate the bending moment value at the section what? XX. Okay. I will calculate the bending moment value at section XX. Right. So let's calculate from left side now. So left side of the section there is only one force of 5 kilonewton is acting. Right. So you are measuring at section XX. What is the perpendicular distance? 1 meter. So about the XX, left side of the force reaction 5 kilonewton is creating a clockwise moment. So what is the force into distance, perpendicular distance? 5 into 1 meter, that is 5 kilonewton meter. Correct or not? So it is creating clockwise, so I have written clockwise only. Okay, now let's calculate from right side of the section. Calculate from right side of the section. You are measuring at section XX. So from right side we have two forces causing a moment about section XS. One is 10, another one is 5 kilonewton. Right. So let's go from 5 kilonewton. 5 kilonewton about section XX, it will create anti-clockwise moment. So I will take minus 5 into distance is how much? 3. Correct or not? Right. Similarly, there is another load 10 kilonewton which is acting perpendicularly at a distance of 1 meter from section XX. It will create a clockwise moment about section XX. So I will take positive 10 into 1. So totally how much it will become? It will become minus 5 kilonewton meter. Correct or not? It will become 5 kilonewton meter. Right. Minus represents means what? It is creating anti-clockwise moment. That's what I represented. Correct. So here you can see at the section XX, left side of the section is creating clockwise moment, right side of the section creating anti-clockwise moment. Finally what it will create? It will try to bend this section like this. That means this is called as what? A sagging bending moment. Right. So hope you would have understood. You have to calculate a bending moment either from left side or right side. Both will give you same result. This is called as what? A bending moment. Now you should know why we will calculate bending moment. Right. So I told, okay, this will create a sagging bending moment. So I have written here a sagging. Okay. This bending is called as what? Arcing. If the left side of the beam is bending in clockwise, right side of these forces are bending in anti-clockwise, it will create a sagging like this. Correct? So if it is reversed, it will create arcing bending moment. What happens if it is sagging or arcing? Arcing means if it is sagging, the bottom fibers will be subjected to tension and top fibers will be subjected to compression. Similarly, if it is arcing, top fibers will be subjected to tension and bottom fibers will be subjected to compression. Okay, concrete is good in compression but weak in tension. To withstand the tension, we will give what? A reinforcement. Right, reinforcement means a steel bars will provide, right? So based on the bending moment value, we will provide longitudinal steel bars. Correct or not? Based on the bending moment value, we will provide longitudinal steel bars. Okay, so bending moment plays a role. What is the intensity of the bending moment? Based on that, we will calculate bending stresses and we will provide longitudinal steel bars. So how sagging and arcing plays a role means, if it is sagging, reinforcement should be given at the bottom. If it is arcing, reinforcement should be given at the top. That is how it helps to differentiate arcing and arcing bending moment. Right? Hope you understood how to calculate a bending moment values. Okay. Now, what do you mean by a point of contraflexure? Okay, consider this is a bending moment diagram. So here it's a point where a bending moment value is changing from positive to negative. That indicates the bending moment is changing from sagging to arcing. Correct or not? That point is called as a point of contraflexure. What is the significance of this one means? So here we have to concentrate that up to here steel was given at the bottom because tension is at the bottom. When it comes to arcing, tension will be at the top. That's why this point plays a major role to represent the variation of from arcing to sagging to arcing. Okay, so how we can define point of contraflexure means the point where bending moment changes its sign from positive to negative. Okay, that point is called as what? Point of contraflexure. Now, where you will get a maximum bending moment. How to identify it? Consider this as a shear force diagram. Okay, wherever shear force changes its sign from positive to negative, at those points you will get what? A maximum bending moment. At those points you will get maximum bending moments. Okay, you remember this one. So why I am telling like this one means, because whenever you are calculating bending moment values, you should calculate at the point where shear force is changing its sign, because there only you are getting what? A maximum bending moment. Okay, now let's go for a sign convention. Okay, if you consider a beam, I told you can calculate from left side or right side, from any of the point. For example, you are calculating at this point, you can calculate from left side or right side. Okay, now if you are measuring the shear force from left side of the beam, you have to take upward as positive, okay, and downward as negative. Remember, okay, if you are measuring from left side of the beam, you have to take upward forces as positive and downward as negative. Similarly, if you are calculating from right side of the beam, you have to take upward as negative and downward as a positive. Now, let's go for a sign convention of bending moment diagram. Okay, when you are calculating bending moment values, I discussed in previous video about a sagging and arcing. Okay, sagging I will take it as positive, arcing I will take it as what? Negative. Sagging means left side of forces are causing clockwise movement, right side forces should cause anti-clockwise movement. Then only it can create what? A positive bending moment, that means sagging bending moment. Or else, if left side of the forces are causing anti-clockwise movement and right side of the forces are causing clockwise movement, it will cause arcing bending moment, which I will treat it as negative. So now, when you are calculating the bending moment from left side of the section, you have to take what? A clockwise as positive and anti-clockwise as what? Negative. Okay. Similarly, if you are calculating bending moment from right side of the beam, what? Clockwise as negative and anti-clockwise as positive. Okay, why? Because here you see the diagram, this is sagging. Clockwise means, if you are calculating from left side, clockwise means it will create sagging. That's why I have taken positive. Similarly, if from the left side, if it is creating anti-clockwise means it is arcing. That's why I have taken negative. If you are measuring from right side, anti-clockwise will cause what? Sagging bending moment. That's why it is positive. Okay. Similarly, clockwise bending moment will cause what? negative, that is Agi. That's why I've taken what? Negative. You may get a doubt, okay, in finding the rotational effect and all. So do one thing, when you're calculating from left side, okay, all the upward forces will cause a clockwise moment. Similarly, downward forces will cause anti-clockwise moment. Okay, same thing. Here, when you're taking from right side, you take all the upward forces as negative, all the downward forces as positive. Because in a beam, upward forces will cause about any section clockwise moment and downward forces will cause always anti-clockwise moment about any point. Okay, that is how you can remember. I suggest better when you initially you follow any one direction either from left or right. You better always go from right, so until unless you will understand the concept properly, so that you can avoid the confusions. Now let us discuss about variation of a shear force and bending moment. How the shear force and bending moment will vary in between the 2 points. Okay, now I have taken here point loads UDL and UVL and how the variation you have to represent. Okay, in between the 2 point loads, shear force will vary constantly. It will be straight line and bending moment will vary linearly. Okay, the variation is linear variation. Similarly, if it is a UDL, uniformly distributed load, between the 2 points of UDL, shear force will vary linearly and bending moment will vary parabolically, second degree parabola, right? If it is a UVL, that is uniformly varying load, or it is also called as what? Triangular load. In between the 2 points, if it is a UVL, the shear force will vary parabolically and bending moment will vary in form of cubic parabola as I represented. Okay, this is how you can understand how to represent the variation of shear force and bending moment between the 2 points whenever it is point loads or UDL or UVL. Okay, thank you.
Subscribe to the channel and press the bell icon for more educational videos.